Okay, so we've actually, the notes on the beginning of this saying exponential equation is an equation with a variable in the exponent. So the exponent has a variable in it. That's an exponential equation. A logarithmic equation is an equation with one or more logarithms involving a variable. So if the logarithm has a variable in it, it is a logarithmic. If none of your logarithms have variables, it's not a logarithmic equation. The log of 5 by itself with no variable is just a number. The logarithm of a number is just another number. So if you see like the log of 5 all by itself, that's a numerical value. X equals the log of 5, that's fine. Okay. Today, the big part is solving exponential equations and logarithmic equations. Basically, every method for solving them, we will cover today. Some of them we've already done. We are going to add to those today. Today is probably one of the most difficult sections. Like I said, this is a difficult chapter. This stuff today covers everything that you need to know about exponentials and logarithms. And we have 4 methods: loop, which we've done; same basis, we haven't done. We've kind of done it, but not formally. We're doing it formally today. Reciprocal powers, straight up off of chapter 6. And the log of both sides. Okay. So, here we go. First one, loop method. We did this. Okay, this is just like what we actually ended on, part of some of the ones we ended on. So I have the log of 4x equals 2. I need to rewrite this as an exponential. Bless you. Bless you. So, when I have a log with no base to it, what's my base? Base 10. This is the common logarithm. Common logarithms are base 10. So that means I have 10 squared equals 4x. Loop it. Now solve for x. 10 squared is 10. 10 squared is 100. 100 equals 4x. Divide by 4, x is 25. Second one. I need to combine them into one logarithm before I loop. So my first step, bring the power up. So I have log base 6 of x squared, and then because it's addition, then it's log base 6 of 4x squared is equal to 2. Because I have to multiply them. When I have addition and multiply, we put it in the correct order. Yes, ma'am. Following the rules of logarithms. I have 3 rules of logarithms that you have to have memorized. You do not have these memorized, you're not going to pass. Nope. If I have the logarithm of 2 things multiplied, that's the log of 2 things added. If I have the log of 2 things added, that's the log of 2 things, two logs added, same base, and it's the log of 2 things multiplied. The log of 2 things divided is the log of the first minus the log of the second. If I have subtraction of logs, that is the first item divided by the second item. If I have a power, I can bring the power down up front or I can put it up. 3 rules of logarithms. For simplifying logs, that's what you do, is you use these 3. Okay? You have to know those rules for this or you can't do it. So that's what I did. Brought up the 2. So that's now x squared. I have plus here, so that means it's x squared times 4x, which is 4x squared. Combined it into one logarithm. Okay. From there, I loop. The base of my logarithm is 6. The base of my power is 6. And just swap those 2 sides. So I have 6 squared equals 4x squared. 36 equals 4x squared. divide both sides by 4. 9 equals x squared. Square root both sides. X equals 3. Same thing. First I have to do, combine it up into one logarithm. I have subtraction, so that converts to division. Log of x over 2 equals 3. Once again, this is a common logarithm because there's no base written. That means it's base 10. So that means I have 10 cubed equals x squared. 10 cubed is 1,000. Times 2 gives me 2,000. Same thing on this one. Combine them up. Log base 8 of 3x over 6 is equal to negative 2. And I can simplify the 3x over 6 at any time I want to do that. I can do it now. So that's log base 8 of x over 2 equals negative 2. Loop it. 8 to the negative 2 power equals x over 2. 8 to the negative 2 is 1 over 8 squared, which is 1 over 64. That's equal to x over 2. Multiply both sides by 2. I get x equals 1 over 32. 2 over 64 reduces to 1 over 32. Okay, this next one's a little more complicated. It still works the same. I have addition, so that means I have the log of x times x minus 3 is equal to 1. Go ahead and loop. 10 to the first. And then distribute the x on this one, so I get x squared minus 3x. Subtract 10 from both sides, because that's 10 to the first. 0 equals x squared minus 3x minus 10. 0 equals x minus 5, x plus 2. 2 times 5 is 10. 2 plus negative 5 is negative 3. X equals 5. X equals negative 2. It's always the base of the base of your logarithm is the base of your power. So here, remember, I have log base 10. So that means I'm going to have 10 to some power. Let me just swap which one's which. So if I look at this one here in particular, so I have a 10 here. So the base of my logarithm is the base of my new power. And then see what I did with the 2 and the 4x? They swap sides. And that comes with practice. Remembering which one goes where, that comes with practice. More than anything else. Questions? Your turn. Do those. Okay, here we go. So on the first one, it's log base 10. So I have 10 cubed equals 4x plus 2. 1,000 equals 4x plus 2. Subtract 2. Ladies, gentlemen, 998 equals 4x. Divide by 4. X equals, does not go in evenly. 249 and a half.
Because I did 4x.
Okay.
Why does it not?
Because 988 is not evenly divisible by
No, I'm
4.
not saying that. I'm saying why is it 1,000 divided by 4 minus 2 or 2, 48?
Okay, order of operations. If you divide by 4 here, you need to divide everything on both sides by 4. If you did not divide the 2 by 4 as well,
Okay, 2 by 4.
because you have to divide everything by 4.
Yeah, so then it'd just be minus a half. So then it would still be 249.
Yeah, and you didn't do that. Okay, next one. Okay, shh. Okay, gentlemen, ladies. Bring up the 2 to get x squared, multiply it out. You get log base 8 of 4x squared is equal to 2. 8 squared equals 4x squared. 64 equals 4x squared. Divide by 4. 16 equals x squared. X equals 4. On the next one, x minus 7, so I get the log of x over 7 is equal to 9. So I get 10 to the 9th is equal to x over 7. So 7 followed by 9 zeros is equal to x.
What?
7 billion.
Saw that.
Okay. Next one, combine them up into 1. So I get log base 4 of 2x over 5 is equal to 3. Loop it, so I get 4 cubed is equal to 2x over 5. 4 cubed is 64. 2x over 5. Multiply by 5, divide by 2. X is 160. And no, these are not the problems you absolutely need your calculator for. And the last example, once again, you multiply them together. So I get the log of x times x minus 9 is equal to 1. Loop it. 10 to the first is equal to x squared minus 9x. Subtract 10 from both sides. 0 equals x squared minus 9x minus 10. Two numbers multiplied to give me 10. Subtract to give me 9. 1 and 10. 0 equals x minus 10. X plus 1. So x equals 10. X equals negative 1. Questions? Okay. Solving using the same base method. Here's what you want to do. You want to make the base of your exponents the same number. You want to make the base of your exponents the same number. So for example, I have 2 to the x equals 32. I need to rewrite 2 as 3 to some power. That's what the same base method means, that I have 2 to the x equals 2 to the something. In this case, 32 is 2 to the 5th power. If the bases are the same and it's equal, that means the exponents have to be the same. So x equals 5. If the bases are the same, the exponents have to be the same. Right? 2 to something equals 2 to something. Those somethings need to be the same something. In this case, x equals 5. I have to have the same base. So in the next one, I have 3 and 27. 27 is 3 cubed. So I rewrite the 27 as 3 cubed. This one's a little more difficult, but it's not that much harder. So I have 3 to the x equals 3 cubed Yeah, clean that up a little bit here. 3 cubed to the x plus 2 power. I changed the 27 to 3 cubed. Now, it's still a little goofy. But what do I have? I have a power to a power. What do you do when you have a power raised to a power? You multiply those exponents. So this is 3 to the x equals 3 to the 3x plus 6. When you raise a power to power, one of the rules of exponents we covered in the last chapter was when you raise a power to power, you multiply the exponents. Now I have the same base. 3 to something equals 3 to something. Those two somethings need to be equal. That means x equals 3x plus 6. Bases are the same. The exponents have to be the same. So subtract 3x, so I get negative 2x equals 6. Divide by negative 2, x equals negative 3. Next one isn't too bad. 36 is 6 to what power? 6 to the 6th power.
No, I mean.
6
right.
what?
6 to the
Second power. 6 squared. 6 squared to the x equals 6 to the x minus 1. 36 is 6 squared. I have the same base, but I have something in parentheses. I need to get rid of that. Multiply the exponents. 6 to the 2x equals 6 to the x minus 1. That means 2x equals x minus 1. Subtract x. X equals negative 1. Same base. That's what we're trying to do here. Get the same base. Something to some power. This next one's a little tricky. I know you're saying, Mr. Orris, they're all hard. Get over it. Okay. 16 and 8 as the same base. 16 is not 8 to some power. It is, but it's not an easy power. It's not like it's 8 squared. 8 squared is not 16. 8 squared is 64. So getting the same base is a little more complicated. But if you stop and think about it, they are both powers of 2. 16 is 2 to the 4th power. So I have 2 to the 4th to the x plus 2. 8 is 2 cubed to the 2x minus 1 power. I rewrote 16 and 8 as powers of 2. I have the same base. They're both powers of the same number. I had to change both of them this time. Because 8 to some power is not 16 or vice versa. I can't change just one of them. I have to change both. Okay. So what do? You multiply the exponents. So this is 2 to the 4x plus 8 equals 2 to the 6x minus 3. So 4x plus 8 equals 6x minus 3. Add 3 to both sides, subtract 4x. I get 11 equals 2x. So x equals 11 halves. Oh my God, a fractional answer. Imagine that. Next one. Can I write 1 over 49 as a power of 7? Yeah. Because 49 is 7 to the what power? 2. 1 over 49 is 7 to the negative 2. Equals 7 to the x minus 5. So that means negative 2 equals x minus 5. Add 5 to both sides. X equals 3. Now the next one's interesting because I have choices on the next one. I have choices on the next one. I can rewrite them both as powers of 5 or as powers of 25.
25.
Either one will work. 25 will give me smaller exponents, but not everybody sees that 625 is 25 squared. It's easier to see them both as powers of 5. Ooh, 25 is 5 squared. It's 625, 5 to some power. So my choices are for this one. I can either write this as 25 to the negative 1 to the x power equals 25 squared, which means negative x equals 2, so x equals negative 2. Or I can rewrite this as 5 to the negative 2 to the x power equals 5 to the 4th, because 625 is 5 to the 4th power. And if you're not sure about something like that, hey, it ends in freaking 25. It's probably 5 to some power. Take 5 squared, multiply that times 5, you get 5 cubed. Multiply that times 5, you get 5 to the 4th. You can do it on your calculator. Do 5 cubed and 5 to the 4th and 5 to the 5th on your calculator to get a number that matches. You can do that. So that means negative 2x equals 4. So guess what? X equals negative 2. Look, I got the same answer using either one. It doesn't matter. Do you see 25 to some power or do you see 5 to some power? Either one works just fine. Okay, it's what you're comfortable with. Your turn, do these. Hey, let's do these. So the first one, 9, I want to rewrite 9 as some power 3. 3 squared to the x equals 3 to the x plus 4. 3 to the 2x equals 3 to the x plus 4. 2x equals x plus 4. Subtract x. X equals 4. Next one, I'm going to write them both as powers of 3. That's the easiest thing to do. 1/3 is 3 to the negative 1. So I get 3 to the negative 1 to the 2x is equal to 3 to the 4th power times x minus 2, or to the x minus 2. So they're both base 3. So that means 3 to the negative 2x equals 3 to the 4x minus 8. So that means that negative 2x equals 4x minus 8. Subtract 2x, negative 6x equals negative 8. X equals 8/6, which is 4/3. So you get 4/3 on that one. Next one, it's not so bad. 16, 2 to the 5x minus 6 equals 2 to the 4th. 5x minus 6 equals 4. Add 6. 5x equals 10. X equals 2. Sometimes they're not that hard. Sometimes. 125 is not a power of 25. However, they're both powers of 5. So this is 5 cubed to the x equals 5 squared to the x plus 3. So that means 5 to the 3x equals 5 to the 2x plus 3. So 3x equals 2x plus 3. Subtract 2x, x equals 3. You're right, plus 6, my bad. Plus 6, plus 6. So x equals 6, my bad, thank you. Next one, 1 over 36. 6 to the negative 2. So 6 to the negative 2 equals 6 to the x plus 9. Negative 2 equals x plus 9. Subtract 9. X equals negative 11. And then the last one, 64 and 8. 64 is 8 squared. So I get 8 squared to the x plus 2 equals 8 to the 4x minus 2. What in the bottom there? There we go. So 8 to the 2x plus 4 equals 8 to the 4x minus 2. So 2x plus 4 equals 4x minus 2. Add 2, subtract 2x. 6 equals 2x. X equals 3. Same base. If you can get the same base, this isn't bad. This is nice. Doesn't always work that way, as we will see. But if you can, this is great. Okay. Now, these ones, reciprocal powers. So, these are not exponential equations. These are equations involving exponents, but they're not exponential equations. Exponential equations would involve the variables being in the exponents. The variables are not being the exponent. I have x to some power, x to some goofy power. The reciprocal power methods means that I need to use reciprocal powers. What my goal is to get x to the first power. To get x to the first power, I need to take this and raise it to its reciprocal power. So x to the 2/3, I need to raise that to the 3/2 power. 3/2 is the reciprocal of 2/3. When you multiply a number times its reciprocal, you get 1. So this will give me on this side x to the first, which is x. That's what I'm looking for. If I raise one side to the 3/2 power, I must raise the other side to the 3/2 power. So what I technically have is x to the first is equal to 4 to the 3/2 power. Now you need to go back and do this, what we did last chapter. Convert that over to a particular number. The 2 in the denominator means that I take the square root. Square root of 4 is 2. So that means I have x equals 2 cubed. So x equals 8. You do that too. So you can take 4 to the 3rd, which is 64, take the square root of 4 of that, which is 8. I'd rather make a number smaller and then raise that to a power than make a number bigger and have to take a root. Does that make sense? Yeah, I'd rather make a number smaller than bigger. So, what's the reciprocal of 1/2? 2. It's 2 over 1, which is 2. So I raise both of these to the second power, which means I have x equals 25, because it's negative 5 squared, not negative 5 squared. I'm squaring everything on that side. What's the difference on the next one before the previous two?
Is that there's
Yeah, it's not just x to some power or there's something else. I need to get x to some power by itself. So my first step is to actually divide both sides by 3. Gives me x to the 3/2 equals 27. What's the reciprocal of 3/2? 2/3. So that means I raise both sides to the 2/3 power. So I get x equals 2/3. The 3 in the denominator means I do a cube root. Cube root of 27 is 3. The 2 means I square that. 3 squared is 9. The next one, I have x to the negative 1/2 power. The reciprocal of negative 1/2 is negative 2. So I take both sides to the negative 2 power, which gives me x to the first 9 to the negative 2 is 1 over 9 squared, which is 81. Okay, next one, I need to get the x by itself first, so my first step is to divide both sides by 5. X to the negative 2/3 is equal to 4. The reciprocal of negative 2/3 is negative 3/2. So I raise both sides to the negative 3/2. I get x equals. The negative means I have 1 over 3/2. The 2 in the denominator means I take the square root. Square root of 4 is 2. The 3 in the numerator means I cube that, which gives me 8. So I get 1/8. Last one, divide both sides by 2 first. X to the negative 1/5 is equal to 2. The reciprocal of negative 1/5 is negative 5. Negative 5 over 1, but negative 5. Raise them both to the negative 5 power. X equals 2 to the negative 5th, which is 1 over 32. Remember, this only works if I have the variable as my base, not as my exponent. Your turn, do those. I know I'm moving kind of quick, but the next section is actually more difficult, so I want to get these ones covered. So to the 2/5 power, the reciprocal is 5/2. So I get x equals square root of 16 is 4. 4 to the 5th power is 1,028. 1,024. Well, I was trying to do 2 to the 10th power because that's what it is. It's the same thing. Okay. The next one, reciprocal of negative 1/4 is negative 4. So I raise them both to the negative 4 power. I get x equals 1 over 81. Next one, I have to divide both sides by 8 first. So I get x to the 1/5 is equal to negative 4. Then I raise both of those to the 5th power. X equals negative 1,024. 4 to the 5th is 1,024, but it's negative and it's an odd power. So your answer will be negative. If it was an even power, you would have a positive answer. Next one, I raise them to the 3/2. So I get x equals, and I do 4 and 9, both the 3/2, or you can leave it as a whole. The 2 means I take the square root. Square root of 4/9 is 2/3. Square root of 4 over the square root of 9.
Well, third question is actually for x equals negative 4 to the
Oh, you're right. That should be what?
3.
3. My bad. Negative 3 to the 5th, which is negative 243.
Yeah, true.
Yeah. My bad. Okay, thanks. So 4/9 gives me 2/3. 2/3 cubed. 2 cubed is 8. 3 cubed is 27. Next one, divide both sides by 7. I get x to the 1/2 equals 7. And then I square both sides. The reciprocal of 1/2 is 2. That gives me x equals 49. Last one, divide both sides by 4. X to the negative 1/3 is equal to 3. Which means I take them both to the negative 3 power. X equals 1/27. Okay. Questions? Now, the next one you absolutely need to have your calculator. This is where logarithms are essential. Okay, these are the types of problems where it is essential that you have logarithms. You cannot solve these problems without logarithms. I have 4 to the x equals 13. If I could write 13 as 4 to some power easily, or make them the same base, write them as both as powers of 2, not a problem. I can do what we were doing earlier, same base. Because my exponent is my variable, I can't use reciprocal powers like we just did. There is one and only one way to solve this problem. Take the log of both sides, and we will be doing common logarithms, which is what the log button on your calculator is. So your first step is to take the log of both sides. So that gives me the log of 4 to the x equals the log of 13. But the exponent's still, the variable's still. What's my rule for exponents and logarithms? Bring it down out in front. So I get x times the log of 4 equals the log of 13. The log of 4 is a number. It's just a number. Log 4 times x is no different than 2x or 3x or negative 5x. It's exactly the same. How would I solve that if it were 2x? I would divide both sides by 2. How do I solve this? Because when it's x times log of 4, I divide both sides by the log of 4. So x equals the log of 13. So I need a little more room. Over the log of 4. This is not 13 over 4. This is not the log of 13 over 4. This is the log of 13 divided by the log of 4. If you type it in any other way, your calculator will not give you the correct answer. Round to 3 decimals. Rarely is this a whole number. If this is a whole number or an easy fraction, you'd be able to do it some other way. So you have to, on your calculator, take the log of 13 and divide that by the log of 4. And you get 1.850.
I got that.
If you did not get that right, you didn't type it right into your calculator. If you don't put parentheses or separate it somehow, your calculator will say, oh, that's the log of 13 divided by the log of 4. So I take 13 divided by the log of 4. If you don't separate it, and then it'll take the log of that number. And if you take the log of 13 divided by 4, it'll take the log of 13 and divide that by 4. You need to take the log of 13, divide that by the log of 4. I did that in 2 steps. You want to do it in one step, put parentheses around them. Parentheses around the log of 13 divided by parentheses around the log of 4. Because if you type it in wrong, you will not get the correct answer even if you're there correct. Because your calculator is stupid and follows order of operations specifically. And if you don't have it typed in correctly, it will do exactly what you tell it to do. Okay. Next one, same idea. First step, take the log of both sides. So I get the log of both sides. So the log of 3x equals the log of 1.9. Guys, bring the x down out in front. X log 3 equals the log of 1.9. Divide both sides by the log of 3. X equals the log of 1.9 divided by the log of 3. .584. Same thing on the next one. First step, take the log of both sides. Now bring the power out in front. What's my power? X plus 1. So I have x plus 1 times the log of 5 is equal to the log of 263. Okay. Divide both sides by the log of 5. Which means you have x plus 1 equals the log of 263 divided by the log of 5. Subtract 1 from both sides there. X equals the log of 263 divided by the log of 5, all minus 1. So you have to do the division of the logs first, then subtract 1 from that number. I get 2.462. Okay, next one. What's my first step going to be on the next one? Subtract 6 from both sides. Get the exponential part by itself first. So my first step on this one, subtract 6 from both sides. So I get 3 to the x is equal to 72. Now you take the log of both sides. So I take the log of both sides, and I end up and bring the power down up front. I get x log 3 equals the log of 72. You have to have the exponential part by itself. Something to the x power or something to a power equals a number, or it doesn't work. Divide both sides by the log of 3. X equals the log of 72 divided by the log of 3. $3.892 or 3.893 rounding. Okay, what's my next step? What's the next one on this? What's my first step on the next one? Divide both sides by 2.
5x equals 238.
Is that right?
Yes.
Yeah, we do want to have a decimal for that. Now take log of both sides. Bring the x down front. X log 5 equals the log of 238.5. Divide both sides by the log of 5. X equals the log of 238.5 divided by the log of 5 gives me 3.41. Next one's actually a little easier in some ways. First step, take the log of both sides. It's already have 7 to some power. So you take the log of both sides, and I bring the 2x out in front. I get 2x log 7 equals the log of 130. It's all multiplication. 2 and log 7 times x. Divide both sides by 2 log 7. So x equals the log of 130 divided by 2 times the log of 7. $1.251.
Oh, I got 1.25.
2507. Rounded off, it's 251.
Okay.
And I would probably accept 7. Okay, next one. This one actually is not that hard. Take the log of both sides. I get the log of 5. Bring the x down front. X log 95. Why is this one confusing? Because I got the variable on the other side. Does it really matter? No. Divide both sides by the log of 95. X equals the log of 5 divided by the log of 95. And I get 0.353. And then last but not least, take the log of both sides. Bring the power down out in front. What's my power on this one? 2x minus 3. So I get 2x minus 3 times the log of 4 equals the log of 263. Divide both sides by the log of 4. So I get 2x minus 3 equals the log of 263 divided by the log of 4. Now, I, generally speaking, do not take my logarithms till the final step because I don't like to round off ahead of time. I let my calculator do all that work at the end. So generally speaking, I don't. Could you do the logarithms now and then add 3 and divide by 2? Yes. If you carried enough decimals on your calculator, you'll still get the same answer. I don't like to do that. So my first step will be to add 3 to both sides. And then what I would do after that is divide both sides by 2. So I end up with, kind of running out of room here, x equals the log of 263 over the log of 4 minus 3, all divided by 2. And then, yes, stick that in your calculator and work it out. Sorry, that should be plus 3. And you get 3.5097, which rounds off to 3.510. When you round off. If you had 509, that'd be okay. Okay, we do not have enough time to go over everything at this point. So your assignment for next week, do these, have these done by the time we come back. And then we'll finish up the lecture notes at that time.